Hello and welcome to my YouTube channel. In this presentation, we are going to see this how to solve this system of equation in two variables. It is solve in R2. The system of equation means we should find a set of vectors in two dimensions. So this is a trick I'll play here. In the first equation from equation 1, I will factor out x I'll factor out y here. Y is common. For this first part, I can factor out y. So that I have y into x squared plus y squared minus 2x equals to 0. Now, when I do that, I can make x squared plus y squared the subject. That will give me 2x over y. Now let's call this equation number 3. Now with that, from equation 2, and no one knows here. From equation 2, we factor out for this first part here, we have that x is common, so we factor out x into y squared plus x squared minus 2y equals to 0. Then let's go ahead and make x squared plus y squared, because x squared plus y squared is the same as x squared. Y squared plus x squared is the same as x squared plus y squared. We make it the subject, you have 2y over x. So let's call this equation number 4. So this is equation number 4. Now observe that here we are dividing by y, so it means that y should be different from 0. And here we are dividing by x, it means x is different from 0. So in the course of solving, we know that x is different from 0 and y is different from 0. Now let's go ahead, and since equation 1, you have x squared plus y squared equals 2x on y. We also have x squared on y squared equals 2y on x. So equation 3 is equals to equation 4. Equation 4, it means that 2x over y is equals to 2y on x. Now let's simplify that. We have 2x squared equals to 2y squared. So it means we divide all through by 2, and I'm going to have x squared equals to y squared, which means that x is equals to y. Since the powers are equal, these values here are equal, right? The bases are equal since the powers are equal. This is from the one-to-one property of index equation. Now with that, since x equals to y, let's call this equation number 5. Equation number 5. So I'll take this one now and replace in any of the original equations. So x equals to y. So let's replace, in place of x we put y, or in place of y we put x. So substitute, we are letting y to be equals to x. From this our equation 5, we let y equals to x, and putting into 1, equation 1 that we had above. Equation 1, I'm going to, in place of y we put x, so I have x squared times x plus x cubed then plus s minus 2x minus 2x equals to 0. So I have x cubed plus x cubed minus 2x equals to 0. Now when you simplify, they have 2x cubed minus 2x equals to 0. It implies x cubed minus x is equals to 0. We can factor out an x, so I have x into x squared minus 1 equals to 0. Factorizing, we still have, this is a difference of 2 squared. It can be factorized as follows: into x minus 1 into x plus 1. Now, since we have this now, this is equal to 0. We know very well that in this system, our x is different from 0 in our solving. And this comes from equation number 4, where we have 2y on x. So we cannot, division by 0 is undefined. So it follows from here that x minus 1 equals to 0 or x plus 1 equals to 0. So I have x equals 1 or x equals to minus 1. Now, these are the only two real solutions, right? Since x equals to y, it implies y will be equals to 1 or y will be equals to minus 1. So the solution in R2 will be a set comprising of the first point, we have x equals 1 and y equals 1, comma, we have x equals -1, y equals -1. So if you take any of these points and substitute in any of those equations, it will satisfy the equation. So thank you for watching, and please subscribe to my YouTube channel if you have not yet subscribed. Share the video and share the video to your mates if you benefit anything from here. And along the process, you can drop any comment that will make me to work harder. Bye bye.